Imagine a structure so massive it could encase an entire star. Capturing every drop of its energy sounds like pure science fiction. Right. Well, this mind-bending concept, known as a Dyson Sphere, might just be humanity's wildest dream of unlimited power. Picture a future where energy shortages and climate crises are relics of the past, all thanks to this cosmic megastructure. But could we actually pull it off, or is this destined to remain sci-fi fantasy? Let's explore the jaw-dropping possibilities and the insane challenges of building a monument to human ambition among the stars. The birth of the Dyson Sphere. From science to science fiction. The idea of a Dyson Sphere didn't originate in Hollywood or the imagination of a novelist. It was proposed by physicist and mathematician Freeman Dyson in 1960. Dyson suggested that an advanced civilization would eventually need to harness the full energy output of its star to sustain its technological growth. Instead of relying on limited planetary resources, they could construct a megastructure to capture and utilize all the star's energy. His hypothesis was inspired by the potential of extraterrestrial life and the evolutionary paths such advanced species might take to ensure survival and progress. This kind of forward thinking reflects humanity's own aspirations for exploring and settling beyond Earth. But let's be clear, Dyson didn't necessarily envision a solid shell around a star. In fact, he theorized a swarm of solar-collecting satellites orbiting the star, each working together to form what's now called a Dyson swarm. Such swarms could be reconfigured and scaled, making them far more practical than a rigid shell. Leave it to sci-fi writers to take this practical idea and turn it into a giant, dramatic sphere that's perfect for a space opera showdown. After all, what's cooler than a civilization powered by an entire sun? These adaptations have allowed the Dyson Sphere to become an enduring symbol of human curiosity and ambition. Why build a Dyson Sphere? The ultimate energy jackpot. To understand why anyone would bother building a Dyson Sphere, consider this. The sun emits about 384.6 yottawatts of energy. Right now, Earth's entire global energy consumption is around 18 terawatts. That's a laughably small fraction compared to what's available. In other words, the sun produces enough energy in a single second to power human civilization for over 1 million years. Let that sink in. Our current reliance on fossil fuels and limited renewable resources only underscores how much we're missing out by not tapping into the vast ocean of solar power directly. But we're barely scratching the surface of that energy potential. The vast majority of solar energy radiates uselessly into space, never touching Earth or any other planetary body. A Dyson Sphere would allow us to harness nearly 100% of that energy output. With such an abundance of power, humanity could achieve technological feats we can't even imagine today. Think interstellar travel, advanced artificial intelligence, and maybe even curing pineapple on pizza debates once and for all. It could also revolutionize healthcare, eliminate energy poverty, and provide power for terraforming other planets. Imagine entire cities powered by a beam of energy from space, not to mention the potential for dramatic reductions in carbon emissions. The engineering nightmare. How do you build a Dyson Sphere? Taking on the engineering nightmare of building a Dyson Sphere starts with solving colossal challenges in materials, energy transmission, and assembly. The first hurdle is acquiring an astronomical amount of materials, potentially by dismantling an entire planet like Mercury, which is rich in metals and close to the sun. Its iron-rich surface makes it a prime candidate, though such an endeavor would require advanced robotics and self-replicating machines far beyond our current capabilities. Lightweight, heat-resistant materials like graphene, carbon nanotubes, or yet-to-be-invented composites would be essential to withstand the sun's intense radiation and gravitational forces. Meanwhile, advancements in asteroid mining could provide additional, more sustainable resources. Capturing solar energy is only part of the problem. Transmitting it back to Earth involves converting it into microwaves or lasers through wireless energy transfer, a concept already demonstrated on a small scale. However, this raises concerns about accuracy, as a misaligned laser could vaporize rather than power homes, while atmospheric interference and long-distance focusing add further complexity. Scientists are investigating orbital relays as a potential solution. The assembly process would require billions of satellites working in perfect harmony, constructed and deployed by autonomous robots and self-replicating machines capable of operating in the harsh conditions of space. This cosmic-scale IKEA project demands breakthroughs in swarm robotics and AI-driven coordination, pushing the boundaries of technology to turn this ambitious vision into a future reality. The challenges. Why we're not quite there yet. The concept of a Dyson Sphere is exhilarating, but the challenges to achieving it are monumental. The energy and cost alone are staggering, with expenses likely to surpass global GDP many times over, making even Elon Musk's Mars ambitions seem trivial. Mining, transporting, and assembling materials on such a scale requires advancements in reusable rockets and space-based manufacturing to bring costs down to feasible levels. On the technological front, we are far from equipped, as current capabilities are akin to asking a toddler to build a skyscraper out of Duplo blocks. However, breakthroughs in nanotechnology, AI, and fusion energy could one day make such a project possible. Additionally, the environmental risks are immense, disrupting the solar system's natural balance or destabilizing planetary orbits by removing materials could lead to catastrophic outcomes, including the loss of Earth's stable climate. Even minor accidents, like a misfired energy beam, could result in continent-wide disasters. Addressing these challenges demands rigorous planning, advanced fail-safes, and incremental progress in space exploration to pave the way for such an ambitious endeavor. Sci-fi to reality. What are scientists saying? Despite these challenges, some scientists believe that a Dyson swarm is theoretically possible eventually. Astrophysicist Mikio Kaku has suggested that building a Dyson sphere is a hallmark of a Type II civilization on the Kardashev scale, a system that measures a civilization's technological advancement based on its energy consumption. For reference, humanity isn't even at Type I yet. We're still stuck burning fossil fuels and arguing over electric cars. According to Kaku, the shift to a Type I civilization could take 100 to 200 years, involving mastery over planetary resources and renewable energy. Kaku predicts that humanity could reach Type II status within a few thousand years. While that timeline sounds discouragingly long, it underscores the potential for exponential growth in technology and resource utilization. So, while we won't be building a Dyson sphere anytime soon, the idea isn't entirely out of the realm of possibility. Every step forward in space exploration, renewable energy, and AI brings us closer to this futuristic milestone. The cultural impact. Dyson spheres in pop culture. The concept of a Dyson sphere has captured the imagination of countless creators and audiences. In Star Trek: The Next Generation, the crew of the USS Enterprise discovers a Dyson sphere containing an entire habitable world inside. Video games like Stellaris allow players to construct Dyson spheres as ultimate power generators. And let's not forget science fiction novels like Larry Niven's Ringworld, which takes the idea of a megastructure to fascinating extremes. These stories don't just entertain, they challenge us to think about what's possible. These depictions not only entertain but also inspire real-world scientists and engineers to think big, really big. After all, today's science fiction often becomes tomorrow's science fact. Whether it's touchscreens inspired by Star Trek or AI assistants like HAL 9000 from 2001. A Space Odyssey, the line between imagination and innovation continues to blur. The Dyson Sphere remains a powerful symbol of what humanity could achieve with enough ambition and ingenuity. Could we actually pull it off? Can humanity build a Dyson Sphere? Not yet, but maybe one day. The challenges are monumental: dismantling planets, advanced robotics, and unimaginable costs. But history proves we thrive on the impossible. Think of the moon landing or the internet. What seems unattainable now could become reality with innovation and determination. For now, it's a dream, a symbol of limitless potential and human ambition, ready to join humanity's journey toward the stars. Don't forget to ignite your curiosity by hitting that like button and subscribing for more mind-blowing explorations of the future. Share this video with your friends, because together, we might just dream big enough to build a Dyson Sphere one day.